Last time we talked about how we can use Ansible to install LXD, and in this video I want to show you how we can use it to remove LXD. We will have to create two roles, one for removing the LXD package and another one to remove the ZFS pool and also to remove the file system signatures on the disk used by the ZFS pool. I have already created my Ansible roles and now I have to remove it so we can create it again. Let's remove LXD, remove, delete, and ZFS destroy pool. And now playbook LXD remove. And I have one more new file. This is just a simple wrapper script, so we can use our Ansible playbook command in the script. We can set our default inventory YAML file, and we can also ask for the become password, which is the sudo password. And at the end of this script, we have a parameter, which means that all of the parameters passed to the script will be also passed to the Ansible playbook command. We could also create a configuration file for Ansible where we can set the default inventory YAML file. And for the become password, we could save the password in a secret. We will have to learn about it later. And I guess I don't have to mention that I have a blog post about this topic, as always, and you can find it on dev.to. In this case, I don't want to follow the structure of the blog post because in the blog post, I wanted to show you how you can start from two simple tasks and then I added more tasks after them and before them, and I also changed the original tasks. That would be hard to follow in a video, so now I want to show you how you can create the final playbook and the final roles. First, I want to check my remote server, so let's go there. I want to see if LXD is installed. It is not installed, so we have to install it. We can use the existing playbook, and I can also use the script which I made to run the playbooks. Before that, I have to activate the Python environment. So I will run an SSH agent for my SSH keys, and then I will activate the environment sourcing homelab.sh. Now I can finally run my playbook LXD install. Now we can go back to the remote server and see if LXD is there. It is there, and we can also use it. Now it's time to remove it again. Let's go to Visual Studio Code and create the role LXD remove. And I also need to create a folder, tasks, and a main YAML in that folder. I will also need another folder called defaults and the main YAML in it. We don't need variables yet, so we can go back to the task file and create the first task. I will copy it from the blog post and we will use the snap module. We will also use the state as absent, not present, since in this case we want to remove this, not install it. And the name is LXD, of course. And we want to run it as root, but first we need to create a playbook. Let's create a new playbook called playbook LXD remove YAML. We can choose a name like remove LXD, and we need to set the hosts. We don't have any categories yet, so we can just use all and use the roles keyword, and now we can define the role, which is LXD remove. And now we can try to run it. Playbook LXD remove YAML and see what happens. We can check the remote server, snap list, and LXD disappeared. The problem is that the ZFS pool is still there, the pool list. And not just that, we can also check snap saved. And as you can see, we have a snapshot of LXD and we don't want to keep the snapshots, so we will remove it later. We can communicate with the snap daemon. Let's go back to the blog post and I will copy this command. We need to use curl. And now we got the list of all snapshots as a JSON. And if I want to make it more user-friendly, I can use the JQ command. And that's it. So our new problem is that we have the LXD snapshot here, and we also have the YQ snapshot, which we don't want to remove. So we will have to add a new parameter to the URL. It is snaps equals LXD. Now run it again. And now the only snapshot we have here is the LXD snapshot. Since I only want to use the snap forget command, which requires the ID of the snapshot, I will need to get the IDs from this JSON list. And I can use the JQ again. As you can see, we have a result section here. So let's get the result only. Now we have it, but the result is a list and I want the ID from all items. I can get all the list items this way. And now I want the IDs from the items. There is only one, and I want to make it a JSON again. So I will use these brackets again around the JQ command, and I finally have a JSON again. Now I want to run it from the Ansible playbook, and before I try to run it in a playbook, I also want to make sure that all of my requirements, curl and JQ is installed on the remote machine. So first I will need a task which can install these packages. And I use a name as a list so I can pass multiple packages to install. And the next is finally the execution of the curl command. Let's copy this too. So I will use the changed when parameter set to false because I don't want Ansible to report this task as changed. And I also use a special syntax for the built-in shell module because I want to use a multi-line command here. I want to register the result of this task, so I will use the register keyword and a variable name after that. Let's create the new task, which is a loop, so we can remove all the snapshots from the list, the JSON list. We need to use the variable which we registered in the previous task, and we need std out from that variable. And since that is just a string and we want to convert it to an object which can be handled by Ansible, we need to use the from JSON filter. And the item is just the loop variable, so it will be the ID. We can try to run it now. First, I want to check my remote server. Snap saved. My snapshot is still there. So let's run playbook LXD remove again. It shows me that it removed the snapshot. I want to check again. My LXD snapshot disappeared, so I can continue with the new task, which will remove the init configuration file, which we saved on the remote server. Let's go to the blog post again, and I will copy the last task. it will use the built-in file module, which we can use to create a folder, or also we can use it to remove a file. Now we need a new variable in the default main YAML, and this will be the path of the init configuration file, which is at /opt /LXD /init YAML. And I also had a line break here. So we are done. Now we can try to run it again. So my init configuration was removed, and the next step is creating the new role, which will remove the ZFS pool. I can also check this. You can see that zpool list still shows this ZFS pool, so I have to remove that too. Let's create the new role. It's called ZFS destroy pool. We need a folder, tasks, and file main YAML, and another folder, defaults, and the main YAML. And now first I want to show you the variables. First variable is ZFS destroy pool name. I want to set the name of the pool, and it must not be empty. However, in this config file, I want to keep it empty because I don't want anyone to accidentally remove something because I had a default value. So the next variable is ZFS destroy pool disks, which will be a list, an empty list, because I have no idea what disks I will use in the future. And this is just a default value. And the final variable here is ZFS destroy pool disks auto detect. And the default value is true. So I want to create a role which can automatically detect which disks I use in a ZFS pool and remove the file system signatures on those disks. On the other hand, I also want to keep the option to manually set those disks. So let's go to the task file. And the first task is variable checking. I don't want anyone to run this role without setting the pool name. And I can use the built-in file module, and I can set the message which will be shown when the task fails. And the condition is that I want it to fail when the ZFS destroy pool name is empty. And the problem is that this variable can be empty in multiple ways. For example, it can be null, it can be none, it can be empty string, or it can also be a string filled with spaces. So I first want to use the default filter and set the default value as empty string. And I also need to use the second parameter as true. It will make sure that even if the variable value is none, null, or empty string, it will apply the default filter. So the next filter is a trim filter, which will make sure that if the variable value was a string filled with spaces, it will trim it, so it will remove the spaces from the value. And if the final result is an empty string, then the task must fail. Let's try this. And first I have to add this role to the playbook. No, it's not LXD, it's ZFS destroy pool. And I don't set the name. And the task fails, so I have to set the name. ZFS destroy pool name, and this is LXD default. Let's run again. It didn't fail, so we can add the new tasks. And the second task will be the confirmation. I want to ask for an input from the user. I will need to use the pause module, and I can set the prompt, which is a message which will be shown when this pause module pauses the execution of the Ansible role. And when the user types something and presses enter, it will be registered in a variable, in the user input variable, which will be found in the registered confirmation prompt variable. Let's try this again. If I just press enter, it can continue. So I need another task which can check the user input. And this is that. And the condition is that the user input must be yes. And if it is not yes, it has to fail. And it seems I failed to copy the task. All right. Now it works. And the message will show the user input so the user can see that. Now we can try this again. Run playbook LXD remove. And I type something, it fails. If I run again, and type yes, exactly, it will continue. So now we can continue with the dangerous tasks. First, we need to check the status of the ZFS pool because we want to remove the ZFS pool only if it is there. So let's add this task at the end of the role. Again, we will register this variable so we can get the status of the task later. And we will need to use this ZFS destroy pool name variable. We have to ignore all the errors because this task will fail if the ZFS pool is not there, but we still need to continue even then. And the next task is interesting. First, I want to show you the result of this zpool list command. Let's run it here. If I just run it without any arguments, zpool list, you can see the list of the pools. We use this command multiple times. If I add -h, then it will ignore the header. Now I also need to use -v. Now I can see the name of the disks, and I will add -p again so I can see the full path of the disks in the ZFS pool. And since I need only the path of the ZFS disks, I will need to add the following lines. And now I get only the path of the disks, and I need only the disks from the ZFS pool I want to remove, which is LXD default. And this is what I will have to use in the playbook. Here I need to use a condition. I only want to run this task when I enabled automatic detection and only when the previous task, the zpool facts task, didn't fail. Let's go back. And the next task is destroying the ZFS pool. And remember, we need to run this task only after we get the information about the disks. Otherwise, there would be no ZFS pool to get the information about. So let's copy destroy ZFS pool task. And I only want to run this when the zpool facts task didn't fail. And I will use the built-in command module. We can try this. And let's run playbook LXD remove. Type yes. And it seems destroy the ZFS pool, change the status of the remote server. We can check this. Zpool list. The ZFS pool disappeared. And the only problem is if I run wipefs --JSON and I pass my disk as the A6. And of course I need to use sudo. Then the file system signatures are still on the disk, so I will have to remove them. Let's go back to the blog post and copy the last task. So again, we will use the built-in command module and wipe the disks which I used in the ZFS pool. And I will need a loop, and in the loop I will need to use multiple variables. And the first is the zpool disks command std outlines, which will contain the list of disks in case I enable the automatic detection. So I can use this variable, but sometimes it will not have a value when the zpool facts task fails. So I will need to use a default filter again and set an empty list as a default value. So if the automatic detection is not enabled, I will need to use the manually set list of disks. And now I can try to run this. Type yes, and nothing happened. And the reason is that when I ran the playbook previously, I already removed the ZFS pool. So now this is the case when I have to set the disks manually. Let's go back to Visual Studio Code and the playbook. And here I can set ZFS destroy pool disks, auto detect false, and ZFS destroy pool disks as a list. And I have a variable in my inventory file which I used when I installed LXD, and all I need is the variable and use it in a template. So let's go and run it again, playbook. Now we know how it works when we set the disks manually, and let's install LXD again. And see what happens when we can detect the disks. In the meantime, I can remove the variables from the playbook. And now I will check the remote server. LXD is here, zpool is here, And my disk, of course, has the file system signatures. And now I can run the playbook again. LXD remove, not install. And Ansible automatically detected my disks, so I don't have LXD anymore. Snap list. I don't have Z pool anymore. Z pool list. And I don't have the file system signatures on the disk. After this video, you finally know how you can install LXD using Ansible, how you can remove it using Ansible. You also learned how you can ask for confirmation from an Ansible playbook, so you can write more secure Ansible roles and playbooks. It is still not for a production environment. We create our roles to use it in our home lab, so we can learn more about virtual machines, LXD, Docker, and anything we want to learn about. If you want to make your roles ready for a production environment, you will have to deal with other issues as well. For example, which I want to show you later, how you can use a secret in an Ansible playbook.